Welcome to this Sahara 4 exercise. In this exercise, we will use the decline window, but instead of declining just the oil rate, we will decline the liquid versus time, the liquid rate versus time, and at the same time, we will decline as well the logarithm of the water oil ratio versus NP, net produce. In this case, this template is especially suitable for wells in secondary recovery because you can use the evolution of the water oil ratio and the NP graph to predict the future oil rate of a well under secondary recovery. So we will now open our Sahara project and we will keep working with the same well that we had before. We will open declines, and now here in the defaults we will select um, a different template. So we have here rate versus time. We have all the different templates available here. So this is the one we will use. This is the total rate of the well versus time on the top, and on the bottom side, on the bottom half, we will have the logarithm of water oil ratio versus the net produce. So we click here, and we have this option available here to link between both regressions. We will see what this refers to in a moment. And now we have our template ready. Here I didn't link both the regressions, so each one is going to be independent. I can decline on one hand the total liquid rate. You can see here that we have a pretty clear behavior here where the liquid rate doesn't really change over time. It's pretty much constant, so we can select it here, and we can use the WOR versus MP. The WOR versus MP, this tendency to predict the behavior of oil over time. That we can see is going to be more or less over here. We can say we can select this one if we want to have a more pessimistic outlook, or something like this. Well, this is quite extreme, but we can select it as well. And let's select the best possible regression. I think it will be something like this. I think it's quite optimistic, but you get the idea. You can use the water oil ratio, the logarithm of water oil ratio versus NP on the y-axis to predict the behavior of the oil phase over time with this liquid rate that we decline here as well. So if you want, you can link both of them here in the forecast options. We can link both regressions, and now both of them are going to be linked if we want to ensure that we are using the same period of time for both of them. So in this case, we can say that this might be a little bit more precise if it's important for us to use the same regression for both the graph on the top, the liquid rate, and the graph at the bottom will be the WOR versus MP. Something important to have in mind as well is that with this kind of templates, we are actually doing two predictions at the same time, because we are predicting based on the calculation of the water ratio. We are predicting the oil forecast, as we can see here, but we are also doing a prediction about the water rate, because the liquid rate is the result of the sum of the water rate and the oil rate. So if we are doing a regression on the liquid rate and a forecast on the liquid rate and also a forecast in the oil rate, logically we are doing as well a forecast on the water rate. So when we save, I will save it now. When we save, I will do forecast here, subphase total. When we do a forecast like this, the thing that is relevant to have in consideration is that we are saving both a forecast of oil and a forecast of water. In the previous exercises, we were saving just the oil, but in this case, we will save both the oil and the water. So we will save here, and now we have this new prediction in the forecast scenario for this well, based on the WOR versus MP and the liquid rate that we have declined here. So that will be everything for this tutorial. I hope it was useful, and thank you for watching.